Imagine a material that is 5 times stronger than steel, but lighter than aluminum. A material used in Formula One cars, aerospace spaceships, and high-end bicycles. You've probably heard of it, carbon fiber. But how is this futuristic material actually made? Spoiler alert, it starts with something you probably have in your house right now. Let's break it down. First, we need to understand what carbon fiber actually is. If you look at a single strand of carbon fiber, it is incredibly thin, about 10 times thinner than a human hair. But inside that tiny strand lies an incredible atomic structure. While steel is heavy because of its dense metallic bonds, carbon fiber relies on the pure, tight bonds of carbon atoms locked together like a microscopic chain link fence. But how do we get these atoms to line up so perfectly? It all starts with a liquid plastic base. About 90% of all carbon fiber is made from a polymer called polyacrylonitrile, or PAN for short. Imagine a long, messy chain of plastic molecules. Right now, it's weak, flexible, and completely useless for building a supercar. To transform it, the liquid plastic is pumped through tiny holes into a chemical bath, turning it into long, continuous white fibers. At this stage, it looks exactly like ordinary yarn. You could literally knit a sweater out of it. But don't wear it to a party just yet, because the magic happens in the ovens. The next step is called stabilization. The white fibers are pulled through huge ovens heated to around 200 to 300 degrees Celsius. As the fibers bake, they absorb oxygen from the air. This causes the molecules inside the plastic to change their chemical structure, locking them into a more stable pattern. During this process, the fiber completely changes color, turning from bright white to jet black. But it's still not carbon fiber. To make it truly indestructible, we need to get rid of everything that isn't carbon. This brings us to carbonization. The black fibers enter a second series of massive ovens, but this time there is no oxygen inside. Instead, the ovens are filled with a gas like nitrogen, and the temperature is cranked up to a mind-blowing 1,000 to 3,000 degrees Celsius. Because there is no oxygen, the fibers don't catch fire. Instead, the extreme heat forces almost all the non-carbon atoms, like hydrogen and nitrogen, to literally evaporate away. What is left behind? A tightly interlocked chain of pure carbon atoms. This is the moment true carbon fiber is born. However, raw carbon fiber is just a very strong thread. If you try to push it, it bends. To make it rigid, it needs a partner. The carbon threads are woven together on giant industrial looms, creating sheets of carbon fiber fabric that look like a high-tech textile. To turn this fabric into a solid object, like a car body or a tennis racket, engineers place the sheets into a mold and coat them with a liquid plastic glue called epoxy resin. Once the resin cures and hardens, the transformation is complete. The carbon fibers handle the tension, the resin handles the compression, and together they form a material so strong that hitting it with a hammer won't even leave a scratch. So, the next time you see a sleek, black patterned piece of carbon fiber on a rocket or a supercar, remember, it started as ordinary liquid plastic, was baked at thousands of degrees, and ended up as one of the strongest materials ever engineered by humans.